Awesome.
With that out of the way, I want to introduce Noah, who's going to be talking about minimal viable Kubernetes.
Cool. Some late-breaking Kubernetes community news. It's like, so kindly said, I am Noah. I do SRE at Geomagical Labs. We're a subsidiary of IKEA. So for work, I do computer vision and augmented reality stuff for home decoration. But I'm not here to talk about that. I'm here to talk about Kubernetes. So let's just jump right in, straight from kubernetes.io. What is Kubernetes? It is an open source system for managing and automating and deploying all of the containerized things, right? If it was that simple, I wouldn't need to be standing up here. If you talk to the core maintainer team, a really common answer you'll hear to what is Kubernetes is an API for systems. So just like POSIX is the standard API to access like file I/O, Kubernetes is an API for your infrastructure. It's not quite the same style as POSIX though. POSIX is more imperative or procedural, one function after the next, whereas Kubernetes is built on desired state config. So it's similar to tools like Puppet and Chef or CF Engine before them, or ditto for Terraform, which brought desired state config into the cloud infrastructure space. This isn't a complete history, that'd be a whole talk on its own, but you can see Kubernetes as the next in sort of a line of tools. Kubernetes as an API isn't just a local thing though, it's an HTTP-based REST API under the hood. And as a bonus, this API can extend itself. It can add new types and operations through the API. This in turn leads to extreme modularity. Two tools can listen for changes on the same API, and they don't have to care about each other. They don't have to be in the same programming language as long as they both speak HTTP. But we're not here to talk about abstract. The real question that most people have is, should I be using this thing? The standard answer I hear to that is Kubernetes is complex and difficult to learn, so you should use it, but only when you get to a certain size. For the biggest of the big, millions of containers across thousands of servers, there's not a lot of other games in town for that kind of scale. As you get big, Kubernetes is cool. But I'm not here for that. As the title said, I'm going to be a contrarian who says that you can and probably should use Kubernetes even with small projects and teams. First, let's talk about some alternatives, though, because I'm sure many of you immediately thought, no way. Small team, I'm not going to use Kubernetes. Too complicated. Plain old Docker is about the simplest you can get. There's some newer tools, stuff like Podman, but they're all basically shaped the same. They all have the same issue in my mind, which is they're not desired state config. They're not designed to operate at large scale. If you've got 10 servers, you've got to go run Docker run on each of them. That's okay for local development when you've only ever got one thing, your laptop, but it's not really great in production even at small sizes. Compose adds desired state config onto Docker, but in turn it's even less remote API friendly, and beyond that, Compose is a pretty simple system. It's not extensible in the same way that a lot of other things are, so if you ever run into like a hard boundary of Compose doesn't do what you need, you've basically got to scrap it and start over. Ansible and Terraform both have container plugins and are plenty extensible. The main downfall for the two of these, for me, is that they're not continually convergent. Or put another way, they only update when you run them. Other than that, it's the Wild West. This leads to drift over time between your desired state and your actual running systems. Many of us have had the moment of terror when we run tfplan and we see a couple hundred lines of diff come out of it. Hosted container run platforms are available from both the main cloud vendors and lots of third parties. These cover a really wide range, but speaking generally, they're going to be more expensive given the same resources compared to just getting a VPS or a physical server. And they have some level of vendor lock-in, usually in the term of proprietary workflow tools. And if we go further down that path, we get functions of service tools like Lambda. These are also going to be yet more expensive, and they level up the vendor lock-in into your actual code, as well as limiting your system architecture to only the things that the platform supports. I don't want to be overly harsh on any of these tools. A common theme that I'm going to come back to over and over in this talk is that small projects start small, but they don't stay small. And while this is just a prototype, I will rewrite it once I get to the real version, is a lovely dream, and I've had it many times myself. It doesn't happen. High-level hosted services can be great. Just understand the limitations and the level of lock-in that you're getting. Make sure you're okay with those downsides. And if you are, and you've got the budget to run them, that's great. You can skip the rest of this talk with my blessing. But for everyone else, let's lay out a baseline persona to talk about. Developer, small team, maybe 1 to 4 people. They've probably got like a single web application, maybe 2 or 3 little ones. And they sit down and think, okay, we've got to launch this product. Maybe let's just get a VPS or a physical server, and we'll apt-get install some stuff on it. There's no dedicated ops team. They've got some budget to work with. but they're still somewhat cost sensitive. Many of you have been on this team in the past, maybe some of you are on this team now. The single biggest reason that I think Kubernetes makes sense, even early on for small teams, is it can grow as the project does. Adding more servers or applications is the most direct form of this, but it goes deeper than that. You can do things like replace your storage provider with just a couple lines of code, or roll out a new networking model without a greenfields rewrite of your entire application. I also really can't understate the value of ecosystem tools. Want a monitoring stack? Installing Prometheus Stack is one command, includes everything you need. Want automatic TLS handling? We've got 5 of those. The modularity of the API makes it really easy to drop things in. Hopefully by now you're at least slightly open to the idea that Kubernetes can be a good idea for small teams, and the next hurdle is to actually do it. And isn't Kubernetes really hard to use? So we come to the really contrarian part. I don't think Kubernetes is hard to use. I think we do a really bad job of explaining Kubernetes to new users. Kubernetes is a hugely flexible and powerful tool. It can do a lot of things. But just like your car can go 100 miles per hour, that doesn't mean you should. And it definitely doesn't mean that you should do that with a new driver. This talk's not going to be about K3S specifically, so I'm not going to dive super deep into it, but I really have to say K3S is the cornerstone of any minimalist Kubernetes setup. It's an all-in-one build of Kubernetes. It removes a lot of the legacy cruft that you wouldn't notice anyway, and it adds support for simpler database options. Is etcd great when you have 1 million containers? Absolutely. Is it complete overkill when we've got 12? Also yes. For the simple case, you've got 1 to 5 little servers, stick with the defaults. Use SQLite as the database, have just one node as the control plane, add in the others as you get them. And you don't even need a dedicated control plane. You can run your own containers on the control plane node. Computers are pretty fast these days. When you start to notice that you're getting limited on resources, then start looking at more complex architectures. What about vendor-hosted Kubernetes? GKE, EKS, AKS, there's lots of acronyms. They're also real good. You'll pay a bit more, both because there's usually some cost overhead on them, and more importantly, because they usually dump in a whole bunch of in-cluster components to integrate with their wider platform, and those are running things, so they take RAM and CPU. You also need to have an account set up with that vendor, which I'm sure for many people in this room right now, that's a no-brainer. Of course, we have a Google account or an AWS account, but in the grand scheme of things, most people don't, and you have to set up billing, and you have to set up permissions, and it is a fair bit of work just to get going with the very first thing on a cloud vendor. But if you've already got that account, or if you can wade through the setup, they're also a good place to start if you've got the budget for it. The real key for making Kubernetes viable for small use cases is to cut down the surface area. Yep, there's 1 million more features that are sitting, waiting to be used. Let them wait. These are the 4 things that you need to get started. And I really mean it. This is as simple as it gets, but you can do real work with this. We'll dive more into how to use those 4 things in a moment, but first, the overarching concept. If you don't know how to do something with Kubernetes, do it the way you would have without Kubernetes, but on Kubernetes. Take the simple approaches. Use the nice-looking tutorials. Will it be perfect? Probably not, but it'll be in a place that you can improve it incrementally as you learn more. The subject matter experts may already be saying, that's ridiculous. If you don't use feature X of Kubernetes, you're going to have problem Y later on. And you're probably right. But sometimes these things, they have to be a journey. If you expect perfection from a new team with minimal support, minimal budget, Kubernetes isn't the problem in this equation. Let people do things the simple way if that's the only way they can start. And you as the senior engineer, you can see 20 moves ahead and see all the pitfalls they're going to hit. That's okay, but if all you do is say, you need to fix this problem without offering to jump in and help them, it's probably not going to be very productive. As we dive into specifics, I'm going to group them into these 3 big categories. Workloads are how you run stuff, networking so they can talk to each other, and storage because we got to put data somewhere. So what do you need to know to actually use Kubernetes? Things run inside a pod, but just every time you hear pod, think container. That's it. They're the same thing. Yes, it is more complicated, but we're just going to move on. We're just going to ignore all of that complexity for right now, and you can just get started. You can create pods directly, but you almost never want to because you'll probably want to use deployments instead. They're a thin wrapper around pods, which handles some of the annoying stuff, dealing with rolling updates and certain types of configuration management. And deployments also add the ability to specify the number of replicas. So if you want to have 5 copies of a thing, instead of having to do it 5 times, you just say 5. If you're looking through a lot of Kubernetes tutorials, you'll see mentions of other workload-related things, stateful sets, daemon sets, jobs. Those do important and special things, and you can ignore them for now. They are important, you will probably want them later, but just not today. Cron jobs, I will, however, give a very slight pass to. I'm not going to cover them here, but if I had to line up everything that you're going to want to learn in order, they're definitely towards the front of that line. But never forget rule 1. Do it the way that you would have before. You can install cron into a container and just run it. That's fine. It's not the fanciest, but it works. Most Kubernetes tutorials, and this talk from here on out, are going to talk about Kubernetes objects in their YAML form, but I do want to at least mention kubectl run. Kubectl run is basically like an upgraded version of Docker run, so you give it the things that you want to run and some information about it, and it will go and do the thing. I don't generally use this even with smaller use cases because I find it very frustrating to work with for iterative development, where you want to start small and then slowly layer on more features. First just get it running and then set some config flags. You can totally do that with kubectl run, but it's going to be up arrow in your terminal, delete, edit it, enter over and over again, and I prefer editing things in my text editor rather than in my shell. All right, let's jump into the YAML side of a deployment. Every Kubernetes YAML starts with these 3 bits of information. The API version and kind, they determine the type of object that it is. API versions, again, it's a whole complex thing. It's related to upgrade paths and compatibility guarantees, and we don't care about that. So really, you just look them up in the documentation and you use whatever the correct one is. The kind is fairly self-explanatory. It's the kind of thing this is, and the name is because if we have more than one thing, we need names to tell the difference between them. Next up, the selector thing. This is the next part of the deployment, and it's annoying. There are technical reasons why we still have to have this in all of the deployments, but it's mostly legacy. Just copy these 8 lines and don't worry about it. The label value doesn't technically have to match the name of the deployment, but why would we make things more complicated for ourselves? So we've got a bit of boilerplate, but this is a full, real example. Yeah, it's a bit redundant. We have to put my app in there 4 separate times, but this isn't rocket science. Every team I've ever worked with can do this. A deployment specification can get way more complicated. Hundreds of lines of YAML, security features, networking features, all of this stuff. But you shouldn't stall out your progress until you can learn those. This really is enough to get started. If you want a tiny bit more than the minimum, here you go. Here's how to override the command that's built into the container. Here's how to add some environment variables. In a lot of cases, you don't need these. But again, if you do, this is not rocket science, and anyone can learn this in an afternoon. This shouldn't be a 4-week intensive training course. It's just a thing you look up. Being able to run software is cool, but usually if we can't talk to it over a network, it's not going to be very useful. In Kubernetes, the main thing that you need to know about networking is that it works kind of like your LAN at home. There's an internal private network. The containers can all talk to each other, and the containers can talk to the internet. But for the internet to talk inwards into a container, we need to poke holes in that private network, which we'll talk about in a second. The private network inside Kubernetes is flat. So every container can talk to every other container. They see each other with the same IPs that they see for themselves. Exactly how this flatness is achieved, again, complicated specification documents, plugins, protocols, etc. We're moving on. It's just a big flat network. And also, like your home network, whenever a new container starts, it gets a dynamic address. It's not actually DHCP, but it has the same effect as DHCP of you can't hardwire IP addresses into places since they might change over time. So we need to use DNS. How do we do that? With a service. A simple service definition does one thing that we care about. This will add a DNS entry into the DNS server that is used by every container automatically so that my app will resolve to the right IP so that things can find your containers. Hooray, we have internal networking. Things can talk to each other. You can use host names instead of IP addresses. Cool. That's internal networking covered. Containers talking to other containers is cool, but I'm selfish. I want to talk to the containers as well. Here we have to introduce a little bit more complexity. The simple and most common case is that you've got something that speaks HTTP or something built on top of HTTP. gRPC, WebSockets, whatever. They're all HTTP as far as we are concerned. For that, you use an ingress. For anything that isn't HTTP-based, you have to use a load balancer service. Well, first you have to be sad that you're using an old and cranky protocol, and then you use a load balancer service. If you followed my advice to use K3S, then you have at least a basic implementation for load balancers. If you're running on a cloud provider, you want to integrate with their vendor-provided load balancer implementation. They've probably already installed the thing that will do that, but if they didn't, that's out of the scope of this talk, but look up their documentation. All right, ingresses. This is our biggest YAML blob yet, and I am sorry for that. Ingresses are an abstraction for HTTP routing and balancing. So it understands host names and it understands path prefixes, and that's about it. It's another plugin-based system. We will see lots of them as we are going through this. But K3S includes an implementation for you, so you don't have to worry about it. You can see at the bottom that it's referencing a service, so ingresses work together with services. The ingress has the sort of HTTP side information, and the service has the how to find the pods and containers information. Once we've created an ingress, then we need to get its IP. This is just like in the olden days where you'd start a server and you have to go get the server's IP address so that you can do something with it. But we can use a command, kubectl describe ingress, and it'll just give us the address. And then you can take that address and you can put that into a DNS, you can put it into a host file, whatever you want to do with it. There are automated tools that'll handle this, but we're starting simple. So, I don't know, like log into your DNS provider and type in that IP address. Cool, you've got a website. On the topic of networking, the other question that I get an awful lot is, should I be using a service mesh? I am not here to praise or vilify service meshes. They do offer some very interesting features, the usual big one for people being automatic internal TLS. If you are in a regulated industry where internal security is at a premium, it is possible that a service mesh from the start is worth the complexity. Otherwise, probably not. I would put them into the not yet bucket. Start small, and you can always add one later. Remember, the entire idea of this is this tool will grow with you over time. You can change systems in a modular way. All right, we can run things. We can talk to them over a network. The last thing we need to deal with is storage. Data storage is easily the hardest of these three main topics we're going to cover. If at all possible, just don't skip it. If you are running in any kind of cloud environment, check if they have a hosted SQL option, hosted object storage like S3 or GCS. If those are what you need for your application, just use the hosted option. It will save you a lot of time. But if that's not an option, or you don't have the budget, there are other options, so we will talk about host storage and cloud volumes. Host path mounts connect a folder from the host system into the container. So you can see at the bottom we have the outside path, and in the middle we have the inside path, and it just connects the two of them. This is really simple, it's very effective, and it matches our rallying cry of do it the same way that you would without Kubernetes. Have data, put it in a folder, problem over. If you've got just a single server, you've booted up on one on-prem machine or you got a VPS somewhere, 100%, just do this. Store data in a folder, you have no more problem. But once you've got more than one server, you've got a problem again. Since the container could run on any of your servers and the data is only on one of them, if the container ends up running somewhere where the data isn't, you will not go to space today. So an easy way to handle that is to just override the automatic container allocation. You can use kubectl, you can get the names of your nodes, find the correct one, and just put a node name into your deployment specification. This isn't great, it has a lot of problems, but if you're just growing from one server to two servers and you need to get that done real fast because you're trying to launch a thing, this is enough. But for a more flexible solution, we need to introduce a new player to the game. So my lie at the beginning, the only need to learn 4 things, begins crumbling. If the simpler approaches to storage aren't good enough, then you will need to learn a 5th thing and a few of its friends. So PVC is a request for a storage volume. It takes information about the type of storage and how big it should be, and then hopefully something off there in the ether will go and create a storage volume for you. So K3S includes a provisioner called local path. This is the same idea as the host path storage. It's just storing it in a folder on the machine, but it does automatically understand where the data is that the container should be running there. So if you're just running on a couple simple boxes and you need to go from 1 to 2 and then 2 to 5, this can be plenty simple. But if you need something more complex, then we need to start talking about cloud volumes, which we'll get to in a second. So using a claim, it's real simple to a host path thing. Remember I keep saying this whole, it's modular, it's modular, it's modular. You change, instead of saying host path, you say persistent volume claim. Instead of giving it a folder path, you give it the name of the claim object. Done. You don't have to change the rest of this. Your application doesn't know that anything different is happening. All right, so cloud volumes. Here's where we need to talk about even more complexity, which makes me a little bit unhappy, but so it goes. So in the olden days, Kubernetes just had a hard-coded set of volume providers, the types of things that it knew how to talk to. But that was kind of annoying because it meant that any updates, you had to wait until there was a new Kubernetes release, and vendors got annoyed because they wanted to add lots of them. And so we added a new plugin system. Plugins all the way down. So this one is called CSI, Container Storage Interface, and it teaches Kubernetes about new types of volumes. Usually with a CSI provider, we will also bundle a little bit of code, a volume provisioner, which knows to watch all of your storage claims and go and actually create the volume that matches your request. Unfortunately, each of these is different depending on your provider. So if you're running on a hosted service, GK or whatever, they've already set this up for you, almost certainly. If you find any problems with it or you want to, figure out more complex features of it, search for name of vendor CSI plugin. You'll find all the documentation. And if you aren't running on a cloud system, or if you are, but for some reason you don't want to use theirs, you can run your own. So K3S doesn't include its own storage system directly, but the same team that writes K3S also works on a storage system called Longhorn, and so naturally that's the one they recommend. Longhorn is fine. It's perfectly good to get you started, but there are a lot of options here. And like I said before, storage is really hard. So if all you need is, one 10 gigabyte volume to store a database on, Longhorn is fine. Any of these are fine. By the time you get up into like the terabytes of data, you should probably look through the documentation on these and figure out, which one would be best for your specific needs. But remember, the whole point of this entire exercise is that you can swap things out later. Heck, you could run all three of these in parallel if you wanted to for some reason. Probably don't, but hey, it's there. We briefly touched on kubectl run, but it warrants a little bit more time in general. So kubectl is the command line tool for interacting with Kubernetes. Some people will say kubectl. Those people are wrong, because I have the microphone right now. Like everything else we've covered, it has approximately 8 million features, and again, we only need a couple of them, probably just these 4. So the single most important kubectl command is kubectl apply. It handles both creating and updating objects. Anytime that you want to change something and it's not a delete, this is the command you're going to probably run. You can give it a path to a single YAML file. You can give it a folder full of YAML files. This isn't super complicated, but it is the workhorse of every Kubernetes workflow somewhere deep down. The other commands that we care about all take the form verb, type, and maybe name. So get is slightly oddly named. Get is actually the list command. So we use this if we want to see either some quick overview about all of a type, or very commonly, if you want to find the actual name of a pod. You may have noticed that pods have some random junk in their name for weird technical reasons. So if you want to find the correct name for the pod today, you need to usually list and then find and copy and paste the right one. Describe gets detailed data on a single object. We saw that before when we were getting the IP address for an ingress, but it works on everything. And delete, it does what it says in the name. It deletes things. And a cool feature of delete is that you can also use the same -f as you did with apply to clean up all of the things that apply created. All right, well, we've covered the basic trifecta you need to use Kubernetes as a small team, at least in my opinion. But obviously, there's a lot more that I didn't cover. I will repeat my claim. Starting small and doing things poorly is okay. You shouldn't have to feel like you have to do everything all at once. But I would like to at least give you a few directions to go in once you're ready for them. We started from this baseline of just get a VPS or just get a single on-prem server and install some stuff on it. And from that, we've inherited no shortage of limitations. The most obvious is that anything past a prototype, you probably need more than one server, hopefully. This is easy enough, especially if you're using a VPS or cloud provider. You just go, you pay for some more instances, and you throw K3S at them. Boom, you've now got a 5-node Kubernetes cluster. Great. But you do need a little bit more than that. It's not enough to just have all the servers. We need to make sure that certain containers are spread out, because if they're all running on one machine, then if that one machine goes down, we're still in the same problem. For that, you can look up pod anti-affinities. Caslin mentioned these a little bit more earlier today. You've also probably got like some database passwords, maybe some API keys, all that kind of stuff. To start with, they live in a YAML file that's on one person's laptop. Okay, that is workable. You can definitely ship software with that, but it's going to start to get in your way more and more as the team grows, as you end up working with more things. So you'll probably eventually want to look up some way to manage those more automatically. Things like monitoring, when you've got one team and everyone is looking at the exact same small code base, you have monitoring by virtue of the people, but as things spread out, as you have more services, you're going to want some more tooling there. So we've got stuff that you can look into. These are all directions that you can go in once you're ready for them. Not today, maybe not tomorrow, but they're there when you need them. You can drop them in easily. You just keep chewing forward. What about all the other fancy things? How will you know when you should look into them? It's a really hard question to answer, as are all unknown unknowns. The whole thrust of this talk has been that you don't need to boil the ocean to get started, but once you've sort of got your footing into Kubernetes, you've maybe shipped a couple things, it wouldn't be a bad idea to take one or two of your team, do some more tutorials, videos, books, whatever learning style matches them best, learn about some of those fancy things, and start to introduce them slowly. Look for things that solve problems. So, if you've got a problem, look for a feature in Kubernetes that will either prevent it or solve it, or whatever happens next time, it will make it better. There's probably that flag or option or field somewhere. So let's summarize a bit. Kubernetes is a solid choice for small teams. If you start small, build up your complexity as your project needs it, and importantly, as your team can support it. Grow into the tools rather than expecting perfection day one. Embrace the modular nature and don't be afraid to swap components as you need more of them. And most of all, treat Kubernetes as something that you're always just going to keep learning about rather than as a thing that you master before you go in. Put all that together and you've got a solid place for any team to start. And this is not at all related to the main thrust of my talk, but I would be remiss to not take advantage of the stage. I am hiring an ML ops engineer. Geomagical.com has more information about that, or come talk to me later. Thank you very much. Any questions?
All right, I'm gonna run the mic so we can get it recorded. So raise your hand if you have a question.
If you're nervous about asking in front of the audience, you can also come up and talk to me afterwards.
What are the benefits of K3s versus, say, micro K8s on a Raspberry Pi?
So this is really aimed at like corporate kind of stuff. You wouldn't, a Raspberry Pi is extremely insufficient for anything that like you'd be doing for work. For a home lab, either is fine. MicroK8s is really just getting you like the core of Kubernetes itself, whereas K3s, as I mentioned a couple times throughout, it includes a whole bunch of extra components. It has an ingress controller, it has a load balancer controller, all that kind of stuff just comes built in. If you're trying to learn Kubernetes, then MicroK8s is better because you're getting sort of the more vanilla experience. But K3s, if you just want to ship some software and you're not here to learn Kubernetes, you're here to like launch a startup or something, then MicroK8s is probably just going to annoy you.
Okay, thank you.
So for using Kubernetes, one of the main things that I've ended up finding difficult was how do we access the data that we are setting up in the containers themselves? Because like we have the persistent volume claim, for example, or we have the host path, but so for host path, we can go find the host wherever it's mounted. But with a persistent volume claim, if we need to pull it out of there and put it into something else, how would we do that?
Easiest way is kubectl-exec. Just log into the container as if it were like the world's tiniest VM and just muck around with it. You can add, for instance, if you're trying to like transfer between two volume providers, you can mount them both into the container and just like cp-r.
Hi, thanks for the talk. What's a good sort of start small, just get something done, backup and restore solution?
So there's really only one that I know of that's open source, and that's Valero. It's not super hard to get started with, but it does require some configuration complexity to deal with where the backups are going to live. But it is the thing to use, so.
And if you're using manifest files, I mean, that is your backup in a lot of cases, where you have a Git repo of manifest files to apply somewhere else.
Yep.
But data depends on because even Valero's not getting EBS volumes and necessarily everything out of the volumes themselves, right?
It supports EBS snapshots and things like that as well. Like Valero is a sort of a full solution. What Justin was mentioning is, if other than your data, if what you're worried about backing up is your infrastructure, you don't necessarily need a backup because you'll just recreate it. You'll just kubectl apply the same things and it'll all just come back up just the way it was before. So you need to back up your data. You sometimes need to back up some sort of like live information, but most of your infrastructure, you sort of get away from thinking about backups because it's all just in code in the first place. Awesome.
All right, so
Thank you very much.
And if you want more K3S, again, we'll have a home lab discussion at 5:15 next door, which is new. And so thank you, Noah, for the talk.